Alright, so in this video we're going to look at order of operations. So the order of operations are just that, how we simplify expressions. So the order in which we do operations. So the first one with this, it says P for PEMDAS. Everyone's familiar with that. I like to call it GIMDAS with a G because it just emphasizes that it's any grouping symbol. And you can see our grouping symbols over here are not just limited to parentheses, but brackets, curly brackets. Also, the square root house will act as a grouping symbol, and the division bar will act as a grouping symbol. So if you have multiple things on the top and bottom of a fraction, that also acts as a grouping symbol. And then from there, once we've taken care of all the grouping symbols, we're going to move to exponents. So exponents are going to be that base to a little power, like we just saw. And then multiplication and division. The big mistake here is that students don't move from left to right. It is not necessarily multiplication first. It is whichever one is on the left all the way until the right. And the same thing is true of addition and subtraction. So with addition and subtraction, once you finish the multiplication division, you do with whatever is on the left first. So let's look at an example in your book. And like in the last video, I would say pause the video, work through this. I've got it on the screen. Pause the video now, work through the problem, and then resume it to check with mine. All right, so hopefully you have tried this, and now you're just checking your work. So when I'm looking at this string of numbers, this expression, I'm looking for any grouping symbols first. And I do have parentheses, so I'm going to do the 4 minus 6 first. 4 minus 6 is going to give me -2. And then I'm going to drop everything down. -2 squared times 8 and all of this. Now I've taken care of the parentheses. I'm looking for my exponents, and I do have an exponent of a 2. Now this -2 squared in parentheses is -2 times -2. So that whole thing is going to give me a positive 4. And if you're going to type them into your calculator, you do have to put it in parentheses. If not, it will not give you the correct answer. And then I'm going to drop everything else down. All right, so from there, I'm done with the exponents. Now I'm going to multiplication and division, and I have to move from left to right. Students will want to do this part first, but there is division before multiplication. So I need to complete the division first. And so 24 divided by 8 is going to give me 3. Drop everything down. And now I complete the multiplication. 3 times 4 is going to give me 12. Drop everything down. And then I'm done with all multiplication and division. And so addition, subtraction, I have addition. 7 plus 12 is going to give me a final answer of 19. All right, so prime versus composite. Prime numbers are natural numbers, 1, 2, 3, 4, 5. Remember, we also called those counting numbers. Greater than 1, that can be, it can be broken down. That can be divided evenly by only 1 and itself. So examples of prime numbers, 2, because 2 is only divided by 2 and 1 evenly. Another one is 5, because I can only write 5 as 5 times 1, or I can only divide it evenly by 5 and 1. 11, etc. And we're actually going to look at all the prime numbers 1 to 100. Composite numbers are really just not prime. They're numbers that can be divided evenly by things other than 1 in itself. So an example of a composite number would be 4, because I can write 4 as 1 times 4, but also I can divide it by 2. Another one would be 12, because I can write it as 1 times 12, 2 times 6, or 3 times 4. So those are composite numbers. So in this next video, we're going to go through this activity and find all of the prime numbers from 1 to 100 using these steps.